Well, hello, Team Java. Today we're going to start a new unit, which is Unit 9. In Unit 9, it's basically called Advanced Array Concepts. Now, there's nothing new about arrays that will be introduced today. We're just going to go through some of the applications that are related to array. And then we're going to talk about some classes that's available in the standard library that contain some functions that's very important that you can use with arrays. And after that, we're going to talk about something that doesn't have to do anything with arrays, but it just looks like it's an array, but in reality, it's not an array. So let's get in then and start. First thing we're going to talk about today is sorting. Now, what is sorting? Basically, if you have a data structure and you have elements, well, by data structure, basically, I mean array, and the data in that array, one of the fundamental operations that you may want to apply to the data that you have is to sort them from the smallest value to the greatest value, or from the greatest value to the smallest value. Now, sort algorithms and sort applications, well, we do have a lot of different types of sort algorithms. Right now in my head, I have like 7 or 8 of them. In this chapter, we're just going to cover the basic 2 ones. The first one's called bubble sort, and the other one's called Insertion Sort. Let me just make sure that those are the 2 that we're going to actually cover. So yes, we're going to talk about the insertion and the bubble sort. How will that work? Well, just before I start, I just need to let you know that we basically, let me just open the painter and see if I can actually explain it here. So first and foremost, we're just going to start with the bubble sort. How do I sort data if an array? Let's just imagine that I do have those values. Let's say 2, 5, 1, 6, and 3, and 4. I'm just going to go very simple. Now, bubble sort basically means, and this is very important to understand the concept, so when I write the code, you'll understand what's going on. What I'm going to do, I'm going to compare the 2 with the 5. And if it happens that the 2 was greater, so let's just talk about elements. So the element that I have here is greater than the element that I have here. What I'm going to do, I'm going to swap them. This will go this way, and this one will go this way. Now, in this case, well, 2 is not greater than 5, so none of that will happen. So everything will stay in its place. Right after that, I move to the next element, which is 5 and 1. And now I compare the 5 with the 1. And if this element was greater than this element, which is, in this case, I'm going to swap them. This will go here, and this will go here. And it looks like we do have a case here where the current element is greater than the next element. So what I'm going to do, basically, I'm going to swap them. So I need to, let's go ahead and erase this, and I'm going to swap them. So let's just go ahead and do that. I'll have 1 here, and I'll have 5 here. Right after that, I'm impressed by my skills of drawing here. After that, I'm going to compare the 5 with the 6. Now no swapping will be done because 5 is not greater than 6. And then after that, I will compare 6 with 3. And then, as you can see here, there will be a swapping because, again, 6 is greater than 3. So we'll do a swapping here. Oops. I didn't meant that to happen. Let's just draw it now again. Let's erase this. And then let's just type or erase them both. So I'll have 3 here, and I'll have 6 here. And again, as you can see here, same concept. I have 6 and 4. 6 is greater than 4, so I'm going to do the swapping again. So we'll have 4 here, and I will have 6 here. Now, am I done? No, I'm not done. But this is basically me finishing the first iteration or the first loop, and I'll have many of them. Now, what you need to understand here is, by the time I'm done with the first loop here, I will give the greatest value to be the last element in that array, which basically makes sense. The greatest value should be at the end of the array if I'm ordering them from the smallest value to the greatest value. So what I'm going to do after that, and this is extremely important, I'm going to do another scan. But in this new scan, there is no need to include 6 anymore because 6 is basically at the right place. So I'm just going to include those elements and not touching the 6. So let's go ahead and do that. Remember, this here will be the point where I'm going to stop. So we do the same thing. 2 and 1. There's no need for a swap. Well, actually, there is no. Sorry. 2 is greater than 1. So this is I need to do a swapping here. So I'll have 1 and 2. So 1 here and 2 here. Now after that I move 2 and 5. Well, 2 is not greater than 5, so it's going to stay in this place. And then I move to 5 and 3. Now since 5 is greater than 3, so I'm going to do the swapping. So let's erase the 5 and erase the 3. So let's just go ahead and do that. This is going to be 3, and this is going to be 5. And then after that, 5 and 4, again, I will have to do a swap again. So let's take that out. And let's take this one out. And I'll put 4 here. And I'll put 5 here. Right after this, I am done. Now just remember, it looks like it's sorted already, but that's not the case all the time. This has just happened by chance. What do I do after that? Well, basically, I just go ahead and repeat the same thing, but at this point, and at this moment, I know for sure that those two elements, the 5 and the 6, are going to be in the right order, so I don't need to touch them anymore. I just need to make sure that I will go ahead and check the 1 and 2 and 3 and 4. Now, what we do usually in this case, I'm going to go ahead and compare 1 with 2. And then I'm going to compare the 2 with the 3. And I'm going to compare the 3 with the 4. And as you can notice here, there will be no swapping. And no swapping basically have one meaning. And I'm going to give you 5 seconds to think about what is that meaning. What if I don't have any swapping? So 1, 2, 3, 4, 5. No swapping basically means that the array is already sorted. And all I have to do, I need to have, let's say, a flag or indicator that will tell me that I didn't do any swap operation. And if I didn't do any swap operation, there's no need for me to continue with the process by comparing and then eliminating the last value, from the searching until I get to one element. If I get to a point where I'm checking, I'm doing my scan, and I'm not swapping anymore, so basically that means I don't have to swap anymore, I don't have to scan anymore, the data is already sorted. This is basically what bubble sort is all about. Now, what I'm going to do, I'm going to post 2 videos. The one that I'm going to create now about the program itself, and then I'm going to look for an animation to explain what I just talked about right now. So let's go ahead and move on to Eclipse. So basically, I need to have an array, so I'm going to go ahead and do that. Let's go with integers. Oops. Integer. Oops, what's going on here? Again, it's English. Why is it writing in Arabic? Oh, here we go now. So integer, and I'll call it numbers equal, and let's just create a list of numbers. So I'm going to go randomly. Here's my list of numbers. Now, the idea here, the implementation, is basically to, let's see here, to have what we call a for loop. So, I'm going to create the first one, and without the updating, and then I'll create the updated version. Oh, sorry, the adapted version, or the better version. So here's what I'm going to do. I'm going to start with the for loop. Now this is basically to scan the elements one by one. Oops, I forgot I'm not supposed to have that there. So I'm going to go here, integer x equals 0. X is less than the size of the elements. I'm just going to count them right now. 1, 2, 3, 4, 5, 6, 7, 8. 8. Now, should I go with 8? Let me just show you here. And I'm going to go x plus plus. I want you to think about this 8 here. 8 here represents the number of elements. Now, what I just said here when I was explaining, I said I'm going to compare the elements that I have right now with the one that's next to it. Now, if I keep this 8 here, I'm going to get to a point where I'm going to compare 8 with the one that's next to it. And as you can see here, there's nothing next to the 8. So what I need to do, I need to stop at 2. Because basically, I'm going to compare 2 with 8, and that's where I have to stop. But if I keep going in my scan and I get to the 8 based on this 8 that I have here, well, it just happened that I had 8 here. Let me change the value here. I'll put, for example, 6 here. So if I keep this 8 here, which represents the number of elements that I have, and I get to the 6, my algorithm basically means I'm going to have to compare 6 with the one that's next to it. And as I said before, there is no next to it. As you can see here, there is no element that's next to the 6, so that will cause a problem. So what I need to do, basically, I need to have the following. Integer size equal, and I'll just go ahead and type numbers dot length. And here, I'm going to type size, but very important, you have to subtract 1 from it. So you don't get all the way to 6, you stop at 2, and 2 is going to be compared with the 6. So that would be my first operation. My next operation, which is a little bit critical and a little bit tricky. Now, what I'm going to do here, and I want you to pay attention to this. Let's see here. Well, I am not sure that I like the way the book is doing it. So let me just give you my version here. It's not really my version, but I'm just going to talk about that in a sec. So we're going to have another for loop. Now, for this for loop, let's just go ahead and put integer j equal. Well, we take the first element and we go to the next element. So I'll just keep it with 0. And then j is less than size minus 1. Did I say j? Okay, let me just change that to be y. And I'll go with y again. And then I'll go y plus plus. Okay, so this needs to be updated. I'm just going to explain how do I do that. But I'm just going to keep going now. If, and this is very important, numbers of I is greater than numbers of, there's no I, there's x and y. So I'm going to start with x equals 0. And well, this will keep x. Oh, I think I made a mistake here. Let me just go and make sure that I am not doing something wrong. Well, this is the bubble sort. Oh yeah, I just realized what am I doing wrong here. This is supposed to be x plus 1. Yep. So I'm comparing x, which equals 0, with, well, actually not x. This is supposed to be x plus 1. Oh, sorry, not x, y, and y plus 1. And if that's the case, let's start from the beginning. This basically will take me through all the elements one by one. 9, 3, 5, 1, 7, 4, and 2. This here is going to take me through the same thing again, but here, basically, I'm going to start with y equals 0 all the way to the end. That's okay. And as you can see here, y and y plus 1. So one element plus the element that's next to it. I keep going with this for loop. So 9 with 3, 3 with 5, 5 with 1, 1 with 7, 7 with 4, 4 with 2, and 2 with 6. Right after I'm done with this, I'm going to go to the next element, which is going to be 3. Well, no, I need to go back to the beginning. So I'm going to go back to 1. Okay, yeah, that's okay. That's okay. I'm going to go back to x equal 1. Well, x is not included in this calculations. So I'm going to go back here again. Same thing. Go from 9 to 3, 3 with 5, 5 with 1, 7 with 4, 4 with 2, and 2 with 6. That's basically where I'm making that mistake. But let me just talk about the swapping here. To swap the operation, I need to have a variable here at the beginning, integer temp. This is the temperature, temporary variable that we're going to use. Here's what I'm going to do. I'm going to come here and say temp equal numbers of, let's say, y plus 1. What am I doing here? I'm basically temporarily storing the value that I have at y plus 1. And I can come here now and say numbers of y plus 1 equal numbers of y. So now I updated. I changed the value. For example, if I'm talking about 9 and 3 here, 3 will be stored in temp, and then 3 will change the value of 3 to hold the value of numbers y, which is 9. Now, what do I have? I have this value and this value to equal 9. But that's not what I want. I want the first one, which is numbers of y, to equal 3. Now, I already lost 3 when I performed this operation, but again, 3 was stored in temp. So I will just put here temp, and I am done. Now, this is, again, not the perfect method because I have a problem here. What I need to do here, basically, I need to reduce the size or the iteration that I have here, the loop that I have here. If you just look here, what I'm doing here, I'm going from 0 all the way to size minus 1. I'm going 0 to size minus 1. Previously, when I was explaining, I was like, with every iteration, by the end of the first iteration, I would give 9 to be stored at the end. So that basically means I am not supposed to include 9 in the calculation anymore. So it's going to be basically size minus, instead of minus 1, it's going to be minus 1 minus another 1. And then the second iteration, I will get 7 to be stored here. So I need to continue the iteration without including those 2 here. The idea here and the key here is to add minus x here to your calculation. So at the beginning, x equals 0, so nothing's going to happen. And then after that, when x equals 1, I'm going to eliminate extra element here, and then the second element and the third element, depending on the value of x. Now, let me just go ahead and create a for loop to show you the results of the execution. So integer I equals 0, I is less than size. And then remember, this is me just showing the values. So system.out.print line, and I'm going to come here in numbers of I and put a semicolon here. It will be a lot if I just put them next to each other. I'll put a space here, and then here I'll just go system.out.print line. A very simple operation in Java, takes forever to print. So let's go ahead and run this, and you'll see, hopefully, that the data is going to be sorted. And here we go. The data is sorted. Now, if I take this one away, it's still going to be sorted, but it's not going to be inefficient because, again, I'm not reducing the size of the second iteration. So I'm just going to, adding this minus x basically will reduce the time it takes for this to execute. Now, as I said before, this is not the perfect case. What I need to do is, what if the data was already sorted? Well, here's what I'm going to do. And this is extremely important. What I'm going to do, I'm going to come here, create a Boolean variable, and I will say sorted. And I am going to assign false to it. Well, you know what, let's make it true. I'll just keep it without assigning anything to it. So what I need to do here, where is this if statement? In here, at this point, after the second for loop, I'm going to come here and say if sorted break. this break basically would take you out of this for loop here. So if the data was already sorted, now he's complaining because they said, well, there's no value assigned to sorted. So what I'm going to do here, at this point, I'm just going to come here and type sorted equal true. I'm going to assume it's true. Now, as I said before, the moment you're going to actually do a swap, that basically means it's not sorted. So I'm going to come here and say sorted equal false. So just stay with me here. If the data that I have here was already sorted, I will get to a point where I'm going to pass all this for loop without performing one swap operation. And if I didn't perform any swap operation, the last value for sorted was true, and because I'm checking it here, it was going to be true, so I'm going to leave the whole thing. Now, let's imagine I performed one swap operation, at least one of them. If that's the case, well, guess what? Sort is going to be set to false, and it's not sorted anymore. So when I'm going to come to this if statement, basically this is not going to be executed, so I have to go back. Now, I finished the first iteration. It wasn't sorted, so I have to go to the second one. And when I was doing the second one, I set the sorted back to be true. And through my second iteration here, I found out that I didn't have to do any swap operation. So basically, the last value sorted was true, so I will leave and break it. This is basically the updated version of the sorted algorithm. As I said before, it's a really, really good idea to understand the concept before you jump into the code. So I'm going to look, try to figure out, and I think there is a lot of videos that shows you the concept implemented in animation, so you'll understand the whole concept. Okay, so the book basically is doing it in a different way. I believe this one could be a little bit easier. Now you can look at the book, or you can go with whatever I'm doing. Either way, that should be fine. The second sorting algorithm is basically called insertion operation. Now, what does insertion basically mean? And again, I am not a big fan of how the book is doing it. So again, I'm not going to force you to use my method, but again, if you feel like doing it, go for it. Now, let's go back to the painting or paint software. I'm going to go ahead and do 2, 5, 1, 6, 3. Let's keep it simple. I just updated this array of numbers that I have here to talk about the insertion sort algorithm. Now, before I say anything, you just need to understand one thing. There's a sorting algorithm called selection sort. The selection sort is the easiest one of all the sort algorithms. Now, the book that we're using decided that we're not going to do the selection sort because selection sort is as simple as the bubble sort. So we are forced to use a little bit more complicated one, which is basically called the insertion sort. Now I'm going to explain the insertion sort using this paint software, and then after that I will show you the implementation of it in Java. And of course, I will upload a video that has some animation to explain how it works, just in case you need a little bit more details. So what is this insertion sort algorithm? Well, the idea is very simple. I'm going to start by dividing my array into 2 arrays. The first one contains only one element, and the other one contains all these elements. And what do I do after that? I take the first element from this second array, and I compare it with the elements that I have in the first array. If it happens that the element that I have here is smaller than the elements that I have here, oh, by the way, I'm making an assumption that this array here is going to be sorted already. And that's the case if you think about it here. Because again, if you have an array that has only one element, basically it's sorted at the beginning. So let's go ahead and keep going with that assumption. So I compare 5 with 3. And if it happened, let's just imagine that 3 was greater than 5. Let's just imagine I have 9 here. If you have a 9 here, basically what's going to happen, you're going to save 5 in a temporary variable, and then you're going to move 3 to have the spot of 5. And then after that, you take 5 and you put it here. Am I doing swapping here? Not necessary. Let's go to the next iteration and you'll understand what do I mean by that. So by the time I'm done comparing this element here with all the elements that I have in this area, what am I going to do? I'm going to move on to the next iteration. Now, let me just show you what's going to happen in the next iteration. In the next iteration, basically, I'm going to still have my array divided. Well, there was no need for me to wipe this out, but I'll just keep going with that. My next time, I'm going to divide my array into two arrays, this one here and this one here. The same assumption that I had before. This one is already sorted, and that's the case, 3 and 5, so it's already sorted. And I'm going to take this element, the one here, and see where is it going to fit here. So let's take this one here as my value. I'm going to create a temp, and I'm going to store 1 in it. So basically, I do have my 1 here stored somewhere. What I'm going to do, I'm going to take this 1, and I'm going to compare it with the elements that I have here. So the first thing, I'm going to compare 1 with 5, and oh, well, basically, yes, 5 is greater than 1. So what I'm going to do, I'm going to wipe the 1, and I'm going to put 5 here. And then after that, I'm not going to wipe anything here. I'm going to go ahead and compare the 3 with the 1. Well, 3 is still greater than 1. So I'm going to take the 3, and I'm going to put store it here. And now, when you get to the first element, all you have to do is to put temp in that first element. So this is basically what I'm going to do. I'm going to take this 3 away, and I'm going to put 1 here. Okay, so I am done with the second iteration. Now let's go ahead and have a look at my array after this. So let's take this away, and let's move this one away, and let's put the line here. Now if you look here, I do have a sorted array 1, 3, 5, and now my new element is basically 6. I'm going to store 6 in this temp variable. And all I'm going to do is I'm going to compare it. I'm just going to compare it here. Sorry, I'm going to store it inside the temp. Well, this phone call has just got me distracted a little bit. So I'm going to put the temp to store 6 inside the temp, and then I'm compare 6 with the 5. And as you can see here, since 6 is greater than 5, or 5 is not greater than 6, there's no need for me to compare with a 3 and 1, because I know this is sorted already. So that's the case, that the first element here is not smaller than the last element in this array. So there's no need to continue with the process. And all I'm going to do is take this one away, take this line away, and have a new line in this area here. Remember, I'm not explaining programming how it works. I'm just explaining the algorithm itself. So 1, 3, 5, 6, and I got 2 here. Now, this is very important to understand. This is a very special case here. It's not actually special. We're going to have this case a lot. I do have a small value here, which is 2. And I'm going to store 2 in temp. And this is what I'm going to do. I'm going to compare. We'll just go ahead and wipe this line here. Let's compare the 2 with the 6. Since 2 is less than 6, so basically 6 will take the place here and be here. And then after that, I'm going to compare the 5 with the 2. Remember, 5 with the 2. Now, since 5 is greater, then the 5 is basically going to take this place. Right after that, I compare the 3 with the 2. And since 3 is greater than 2, then the 3 is going to take the place of the original 5. And now I compare 1 with 2. Since 1 is not greater than 2, then all I have to do is to replace this 3 here with that 2. Let's go ahead and do that. So I'll get 2 here in the right place. And now I am done with this iteration. Take this one away. And then after that, increase the size of the array. So 6 is going to be basically included. And I am done with this iteration. Now all I have to do is to compare the 4, and actually let's store 4 here. And then I will compare 4 with 6. Well, 6 is going to take the place here. And then 5 and 4. 5 is going to take the place here. And then 3 and 4, well, since 4 is greater than 3, there is no need to do anything. Just basically 4 will take the place here. After that, I move to the second iteration, which basically I will have 8 left here. So I'll have 1, 2, 3, 4, 5, 6, and there's no need for swapping anything, and I'm done. This is basically how the insertion sort works. So bottom line, you basically will divide your array into 2 arrays. One of them is already sorted and the other one is not. You take the first element of the not sorted array and you compare with the elements of the sorted array. If the elements from the last one all the way to the beginning, if it happens that you find an element that is greater than the first element in the unsorted array, you basically will take the copy it to that position and move. It's more like shifting the elements one step to the right until you get to the beginning of the array, the sorted array, or until you get to a point where, well, the current element is not actually greater than the element that I have in temp. If that's the case, you stop the process. So I am going to wipe out this, Control N, and I'm going to move to the implementation. And the implementation, as I said before, it's not that complicated. What I'm going to do, I'm going to copy this, same array. I'm going to copy it here, and I'm going to go down in this area here. And let's just put numbers 1, just to make it different. I'm going to put a comment here, just to know what's going on here. This is insertion sort. And the first one was bubble sort. Bubble sort. Okay. Now let's go to the implementation. The implementation is not going to be that easy, but just go with it. So what I'm going to say here, I'm going to start with creating an integer. And let's say here, what am I going to call this integer? Now, since the first index here is 0, I'm always going to be aiming for this value, which is the second index here. So I'm going to just call it index. And let's set that to 1. Now, I'm going to have a while loop. And in this while loop, this is very important, at the very bottom of it, I'm just going to say index plus plus or plus plus index. So I'm going to be moving on to the next element. And what I'm going to do here, as long as index is basically less than the size, so since I'm using the same size, there's no need for me to repeat that function. I'm using basically the size that I have here, especially that I'm using the same array. So if that's the case, index, as long as index is less than size, remember, we started with 1 here, so we're going to increase it 1 by 1 until we get to the end of it, until we get to 6. As long as this condition, keep going here. Now, what do I need to do here? Well, let's start with creating a temporary variable, integer temp, and inside this temp, I'm basically going to store numbers 1 here of index, semicolon. So what I did here, basically at this line, he doesn't, well, it should work, but oh, since I think I already have a temp here, so I'm going to call this one temp1. Okay, so it would make more sense if I declare temp1 outside. I don't declare the variable every time I'm going to use it. So let's go ahead and create that. So what I'm going to do, basically, I'm going to store the value of 3 in this case inside temp1. And most importantly, I need to know the index of the value before it, which is the index of 9. So I'm going to create, well, let's just go ahead and create that variable here. Index C, which is 1. And I'm going to create another index B. C for current and B for before. It's going to be basically, let's just keep it without a variable because we're going to have to do it here. And let's put C here, put C here, put C here. And I'm going to come here and actually index B equal index C minus 1. So when index C equals 3, then index B is going to equal 0. So this one is going to point here, and the other one is going to be pointing here. Now, what I'm going to do here, I'm going to come here and create a while loop. And in this while loop, this is where I'm going to actually update my values. Now, I need to be very, very sure about what I'm going to be doing in this area. Number one, I'm going to put a condition here, and I will say, as long as index B is greater or equal 0. That's my first condition. That basically means I didn't get to the end of it. As long as the value is greater or equal. So I'm going to go, for example, at this point, let's say that was index B. As long as B is greater or equal 0, so basically that will cover all the elements that I have here. If that's the case, that will be number one. Number two, and this is very important, numbers 1 of index B should be, IND. If that value is basically greater than temp, temp 1, what am I going to be doing here? Well, basically, as I said before, and this is very important, look what I'm doing here. I'm saying, as long as B is greater or equal 0, which basically in this case it is equal 0, that's number one. Number two, as long as the value of index of B, which is basically in this case is this one, if that value was greater than the temp, which is basically where I start this, if this value is greater than this value, this is what I'm going to do, and this is very important. I'm going to go to that value, which is 3 in this case. I'm going to say this. I'm going to come and basically just say numbers 1 of index B minus 1, plus 1 equal numbers 1 of B. So what did I just did here? Basically, what is index B, index B. What is index B? Basically, index B is 9. What is index B plus 1, which is 3? So basically, I'm taking this 9 and assigning it to the 3. Right after that, I have to come here and type minus index B, subtract 1 by it. So by the time I'm done with assigning 9 to this element, I'm subtracting 1 from index, which in this case is going to equal -1, because what was the value here? Where is it? This was 0, so subtracting 1 from 0 is -1. So this condition is not true anymore, so I'm going to leave. Right after you leave, basically what you have to do, you need to make sure that the new value here, since this is going to be 9, I need to assign the new value, which was the temp, which in this case was, where is it? Where did I do it? Here. This is where I assigned temp 1 to equal 3. I need to make sure that 3 will be assigned to this value. Now, just remember, numbers 1. If I put B, what was the, index B. Index B. What was the last value of index B? Well, we said -1. So all I have to just push it by 1. And then assigned temp 1 to it. And that basically how the insertion sort works. As I said, it's not the easiest one, but again, it's not that complicated. Just remember, I'm going to go through the algorithm again with you. So I've got my array here. I created 3 variables, one of them temp1, index B, index C. Now, index C, as I said before, is going to be pointing to this element, which is the second element in my array. And this is going to be updated, of course, inside this while loop, as you can see here. Is going to be increased by 1. So we go to the next element. Now what I'm going to do, I'm going to assign the value that's stored here to a temporary variable, and then I'm going to assign index B to the element that's before it. So if I got 3, then this is going to be the element that's before 3. If I'm talking about 5, then this 3 is going to be the element before it. So basically, I got an index to indicate what will be the elements that's before the current element that I'm highlighting with the index C. I do have this while loop. In this while loop, basically, I am going to decrease the value of index B by 1. With every single iteration, this is what I'm doing. As long as the value was greater or equal 0 for index B, but at the same time, this is very important, the value that you have that you're pointing by index B is actually greater than the temp. So this value should be greater than this one. Now, for example, when I'm going to go 3 is going to be here and 9 is going to be here, I got 5 and I got 9. Well, that's another case where the 5 is going to be swapped. But yeah, I think this is going to go until I got 9 at the end. Anyway, as long as this condition is going to be true, you're basically going to assign the value you have at b, which is, for example, in this case 9, to the element that's after 9, which is 3. And then you're going to subtract 1 from the index b. Right after you're done with this while loop, where one of those two conditions became false, all you have to do just to make sure that the temp will be assigned to the right value, which is in this case is going to be whatever the last value of index b, you just have to add 1 to it, so you're going to have the right order. You'll assign temp 1 to it, and then remember you increase your index c to go to the next element. Now, I'm just going to show you at the end of this first iteration, I will get 3, 9, 5, 1, 7, 4, 2, and then 6. Now, after this iteration, basically, index of C is going to be pointing to 5, then index of B is going to be pointing to 9, and index 10th one is going to equal 5. And what I'm going to do here, basically, I'm going to say as long as index B, which is basically equal 1, which is true, I'm going to compare that index, which is 9, with the temp, which is 5. And if that's the case, I'm going to basically change the value of 5 to equal 9. So basically 9 is going to be here, and 9 is going to be here. Remember, we got temp still stored, the value of 5 is still stored in temp 1. Now, right after that, I am going to subtract 1 from index B, which basically means we're going to be pointing at 3. Still true, it's 0, so 0 is greater than that. But look at this case. The index here of B, which is 3, is not greater than 5. So that condition here is not true anymore. So the last value of num0, which basically was 0, is what I'm going to do. I'm going to increase it by 1, so I'm going to be pointing to 9. And whatever temp is going to be basically replacing this 9, so I'll get 5 here. And then after that, I'll increase num by 1, so instead of pointing to 9, I'm going to be pointing to 1, and you keep going that way. Now that I'm done with that, let's go ahead and give this a try. And I promise you, this is like the most complicated part in this chapter, those sort algorithms. Let's run it, and I'm supposed to get, of course I forgot, let's just put, I did have it somewhere, not here. Print, go to the next line, where is it? Here it is. So let me copy this and put it here. Let's give this a try again. And here we go. So those are my two sort algorithms, and now we can move on to the next topic. So let's start talking about a new topic, which is the multi-dimension arrays. Now, let's start with the two-dimension array. What is a two-dimension array? Well, we talked about arrays so far, and if I show you the arrays that we created, which basically this is one of them, this is basically considered a single or a one-dimension array. What we can do, we can have multi-dimension array, or we can have two-dimension array. Sometimes the idea is hard to get or understand, but think about a two-dimension array as a point in a piece of paper. It basically has an x coordinator and it has an x and y values to describe the location of that point in that piece of paper. And now if you want to think about that point in a three-dimensional space, you can add z to that part. So this is basically what two dimensions or multi-dimension arrays now. How do we create two-dimension arrays? And then after that, we'll talk about how to create three-dimension arrays. The idea is very simple. Just like how do we create a single dimension, basically I'll go integer, open a square, and open another square. So see, this is the difference. This is two-dimension. I will call it my array. And then after that, new integer, and then tell me, about how many rows you will have in this dimension. For example, I'll go 3, and how many columns you will have, 4 or 5. Think about a two-dimension array as a table that has rows and columns. That's basically what a two-dimension array is. And now if I want to have access to those elements, well, basically, let's say I want to get access to the first element, the top left corner elements? Well, basically my array of, I have to specify the indexes, both of them. Let's just send that to 100. And that's basically how it works. Now, a little bit of details about this two-dimension array. If I want to have access to, if I want to know the size of this array, well, let's just go ahead and show you what am I going to get if I try that. System.out.print line, and let's type my array.length. Now, this function here, since we have two-dimension, okay, this is out. Since I have two-dimension array, this function here, length, when you apply it to a two-dimension array, is going to just tell you how many rows do you have. So let me just run it, and you'll see it's telling me I have 3 rows. Now the question is, what if I want to know how many columns do I have? Well, you just have to come here and specify a number here, which basically between 0 and 2, and that basically how many columns you have in a single row. So I'm going to go, for example, type 1, and that basically 0, and that basically will tell you that you have 5 columns, in that row. Well, this is basically me creating the array without initializing it. Now, what if I want to actually initialize it, just like how I did here? Well, we'll just copy this, and I'll show you how to do that in a sec. Equal, and I'll open close. Now, what I'm going to do here, since I have 3 rows, this is what I can do. I'll have the first row, put a comma, go next, second row, put a comma, and then next, and then the third row, and there's no need for a comma. Now in this area, I have 5 columns, so 1, 2, 3, 4, and 5. I can come here and put 5, 4, 3, 2, and 1, and here I can put 1, 1, 2, 2, and 3. That's basically how I create the array and initialize it at the same time. What else? Now, we have a very special two-dimension array in Java, which basically in other programming language you may not be able to do that, especially, for example, C++. I have what we call a jagged array. Now, jagged array basically, it has a number of rows, but the number of columns are not necessarily the same. In this case, for example, I specified that the row is 3 and the number of columns for each row is 5. Here, I'm creating 3 rows. Each row basically have 5 columns. But actually, I can do this, and Java would not be mad about this. And I can have only one element, if I will. This is basically what we call a jagged two-dimensional array, and very important to understand. As you see here, I got 3 elements here. I have a lot more than 3 elements, and here I have 1 elements. Now, of course, every time you're going to call this function, it's going to give you different values. For example, if I run it now, there's going to be 3. Now, if I run and put 1, it's not going to be 3 anymore. It's going to be basically how many elements do I have here, which basically is 8. And if I put 2 here, and that will tell me 1. Now, what if I put 3 here? Well, this is where an error will jump and tell you, well, you don't have a 4th row in this, and this is what the exception. It's called array out of bounds exception. So you just always have to be careful when you try to have access to elements of an array. This is basically everything I want to talk about when it comes to multi-dimension array. You can have 3, you can have 4, you can have 5. And I remember one time I was working with an array, and I basically had around 18 or 20 dimension of an array. Of course, the more dimension you have, the heavier the process will be. And you need a supercomputer to be able to process those high dimension arrays. The other part, or the other topic that I want to talk about here, is Java usually come with a class. It's called arrays. This class basically provides you with a list of functions that can make your job a lot easier when you deal with arrays. So from now on, every time you work on a project or something, every time you want to work with arrays, immediately think about that array class. So for example, I'm going to show you the list of those functions. Where is it? Here it is. This is the list of those functions. We have binary search, we have equals, we have fill, we have sort, we have another sort, we have parallel sort. I'm going to talk about them all in a sec. But let's just go ahead and talk about the easiest one, which is basically fill. So I'm going to create an array here. Let's say integer. I'm going to call it num equal new integer. And I'll put the size to be 100. Now, what if I want to fill those 100 elements with the value 9? So this is what I can do. I can call the class arrays.fill, and then in this area, you type the name of the array, and then you type the value you want it to get populated by. Now, anyway, is going to tell you that, oh, this is supposed to be arrays number 1. It's not array. And number 2, I need to import the array class. So let's go all the way to the top, and here we go, util arrays Java. Now, basically, the array num will be filled with the value 9. That's one of the functions. Now, what else? Let's go, not you. Let's go and check the other functions. What is this? We have binary search, and we have equals. Okay. Binary search, it's a way that we can search an array. It's a faster. Now, in the previous chapter, we talked about how do we search an array for a value. We had that special index with a -1 value. Now, we have another algorithm for searching called binary search, which is it's actually not supposed to, it is faster than the linear search. Now, since this is the class of basics, I'm not going to get into the details of how binary search work, but I'm just going to show you how do we use it. So I will come here, copy this, like I can't type arrays, and then I'll type binary search. Now, I'm pretty sure I didn't use the right spell or the capitalization, so it's supposed to be uppercase S. Where is it? Binary search. Now we need to, first of all, we need to figure out what will be the return data type. This function basically is going to return an integer, which is the index or the value you're looking for. And you have to type or pass the array and pass the value you're looking for. So what I'm going to do, where is it? This array here. Let's copy this and go down and create a new one. This time I'm going to call it numbers 2. Now I'm going to pass numbers 2, and I'm looking for the value 4, for example. Now remember, this will return an integer, so I am going to create an integer. I will call it index or indexy or whatever, just make it different. And let's show the value of indexy. System .out.print line. I'm pretty sure the value is going to be a little bit weird and different than what you think it should be. So let's run this first. And look at this. It's telling me it's located at 5. So 0, 1, 2, 3, 4, 5. Well, that worked. Let me look for the value 2. And look at this. So I'm looking for 2. It's giving me -5. That's weird. That's really, really weird. Let's look for the value 1. And let's run it. And it's telling me it's at location 3, which is 0, 1, 2, 3. Okay, that sounds like good. Let me put 3. And again, -5. But again, I'm looking for 3, so it should be here. As you can see here, this binary search is not giving me the right answer. Well, actually, it's not giving. It's not the problem is not with a binary search. The problem is with me. Now, binary search, let me just tell you here, it's designed to search for a value inside an array that is sorted. Now, what I'm passing here, the array that I'm passing here is not sorted, as you can see here. So for this to work, you basically need to sort the array first. So how do I sort the array? Well, let's go back to the functions. We have a function called sort. Where is it? Here it is. And this basically is not going to return anything. It's just going to sort the array A. So I need to come here and type arrays dot sort, and I'm typing numbers 2. Now, when I'm going to be searching for 1, where do you think 1 is going to be after this will be sorted? It's going to be the first element. So let's run that and see if that's the case. And here it is, 0. Now let's search for 2, the one that gave me a -5. Now it's 1, because it's, again, after 1, after you sort this. Let me search for 5. Again, if I can just print this array sorted, you will notice that 5 actually is going to be located at number 4. So binary search, if you want to use binary search, you need to sort the array first, and because sorting by itself, it's a complicated process, so basically no matter what time you're saving here, you're going to be wasting that time in the sort algorithm. Binary search will work perfectly fine if the data that you have has been already sorted or was entered by the user in a sorted way. Otherwise, if you have to sort it, basically you're going to be wasting more time than the time that you're going to save using this fast algorithm. Now, we do have another sort algorithm. It's called parallel sort, which is here. This is the parallel sort. So I don't make mistakes. Are you going to let me copy it? No, of course. Let's just type it then. Let's go back and check. I think I misspelled something. P-A-R-A. Yeah, P-A. Here we go. So parallel sort, what is the difference? Well, sort and parallel sort basically will give you the same exact results. The difference between them, the technique is used in the parallel sort, is basically called merge and sort. And the idea here is basically they're going to just divide the big array into multiple small arrays, and then until they get the array with 2 elements, so sorting is going to be a lot easier than they put it all back together. It's a kind of technique called recursion or divide and conquer, which basically, again, you don't have to worry about that. You just need to know that you have 2 algorithms for sorting. So we have 2 algorithms for sorting. One of them is the tradition sort, and the other one is the parallel sort. As you can see, there's another type of parallel sort, which basically you can specify the specific group of values you want to sort using the sort or parallel sort, which is, again, not a big deal. The last function that we're going to talk about, which is basically equals. Now, this is a really big deal here. Don't change that. Now, whenever I want to compare 2 arrays, and this is extremely important. For example, let's take numbers 2 here. Well, no, let's not take numbers 2. Let's go back to the beginning. Numbers versus numbers 1. Just imagine before we do the sorting. As you can see here, they're exactly the same. Now, if I want to compare them, this is extremely important. I could come here and say if numbers double equal numbers 1. Now, this basically is not complaining about anything, but it's not actually comparing the arrays. It's basically what I'm doing here. I'm asking, is numbers basically pointing to the same memory location for numbers 1? So I'm not comparing the values, I'm comparing and checking if both of those arrays are referencing the same spot or the same space inside the memory. And again, if they have the same values, we know they're going to be pointing to the same space in the memory. But again, that's not the case. What if I want to actually compare the values of 2 arrays? Well, this is what we do. I'm going to come here and I'm going to say arrays dot equal, and let me just make sure that there's no S or something here, just like I thought, equals. And then you have to tell me those 2 arrays. So you can go here, numbers 1, numbers 2. So that's basically telling me if both of those arrays are having the exact same values, then that basically will be true. So I'll just go ahead, system.out.println. We'll just type yes, else no. Okay. What else? So those are the functions basically that comes with the class arrays. We covered that in those examples. Now we do have another important type of arrays. Well, let me just tell you, it's not an array. Let me just put it that way. But it just shares the same name. It's called an array list. Now, what is an array list? The biggest difference, let me just divide this so we move on to another topic. What is an array list? Well, let's go back to this array, for example. When I created this array, one very important fact is that I need to specify the size here. I need to have a number here. I cannot create an array without having a number here. And once that number is entered, then that will be it. This will be the size of your array. It's going to have 100 elements. It cannot pass that. It could be less than that. And that's one of the biggest problems with arrays. They need to tell me the size of the array when you create an array. And then, well, if that's the case, let's just start with a big value. Well, what if I create an array with 1,000,000 values or 1,000,000 elements? Okay, that's possible, but the question is, what if I just needed 5 of them? Then basically I'm going to be reserving space and I'm going to be using it. So that's a bad strategy. Now, what if I decided to go with the exact number of elements that I want, which is, let's say, 5? Well, I can do that. I'll go with 5. Good memory management. But what if in the middle of execution, I figured out I need a space for another element? So the array is supposed to be 6. Well, too bad. You cannot change anything about that. Well, the array list came to solve this problem. Array list, basically, when you create, it's going to be empty. And then you can add elements to it. As you add elements to it, the size of the array extend. And when you start removing elements from it, it shrunk. So this is the beauty of array list. Of course, that comes with a price. I don't want to talk about the price right now. But let's just go ahead and the price is the memory that's going to be reserved for that array. Oh no, sorry, it's not the memory. It's the access. Arrays, those arrays that we created is basically called direct access. So if I ask to go and have access to the 5th element, you can directly go have access to the 5th element. But with array list, that doesn't work. Arrays, let me just put it this way so you'll understand it. Array list works exactly like the cassette tapes that we used to use in the 80s to listen to music. If I like song number 5, then I have to hear the first 4 songs to be able to get to the 5th song. That's basically how the array list works. So let's go ahead and do that and show you how to create an array list. You start with array list. And I need to make sure again that I am using the right name for the class. Yes, array list. Now, very important, which makes it a little bit different, you have to come here and tell me what is the data type that you can use for this array list. And I'm going to call it AL. And then you go new array list. And then again, you type the data type. And I think here you put this empty. It's complaining about the integer. Let me put that. The complete reference type. Well, let me just go and check and see why is it complaining about that. So array list string names new. Well, that's weird. I'm not supposed to use integers. Syntax error. Insert dimension to complete the reference type. Well, let me just go with string, just like the book wants us to do. I'm going to go ahead and look why is it acting this way. Now I need to import the array list. And if you look here, basically both of them are located inside the util, so that's how it works. I'm going to change this to integer. It should work. I don't know why is it complaining. No, it doesn't like it. That is weird. I'm going to go to the documentation of this. I don't use it that much, so that's why I don't really remember it. But let's just do a really quick search. Java array list. Number one, let me just tell you some information about array list. You notice this weird thing that I have here, specifying the data type with a less than or greater than symbols here. This here basically means this is a template. And templates, it's a big deal when it comes to programming, especially when it comes to something we call generic coding. We don't have to worry about it here. This is a little bit advanced. So we'll just keep it simple right now. And when you guys get to the point to study the OOP of JavaScript, you will have a chance to know what is this. So here we go. Let's go to this W3's colon and see what they say about this. Array list is a resizable array which has found in the Java util package. The difference between a built-in array and this array is the size of the array cannot be modified. That's basically what's inside the traditional array. Well, here the size can go up and down. String. He's using string here as well. Create an array of list of objects. He's going with a string. But then he's going to talk about those methods. So that's not the point here. I want an array list. Let me just type this and see. Array list. An integer is a value, and array list required its implementation reference type. Okay, that's why. Okay, that makes sense. In this area, you're not allowed to have primitive data types. Let me just simplify it that way. It has to be reference objects. So if you want to actually have an integer, there's a class called integers, and you can actually put integers there. Which again, I don't remember if we talked about the class integers or not. So let's just go with the strings here. Okay, so here we go. Now, the methods that comes with this class, basically I have a list here. You can add, and basically whenever you add an element, it's going to go to the end of the list, and it's going to add it to the end of the list. When you want to add an element into a specific place, you have to tell me the location of that place you want to enter. Now, whenever you want to remove a value, well, basically, you can just tell me the value, the location of the value you're trying to remove from the list. And if you want to change the value, basically, you specify the location of the value and the new value you want to replace the old value. If you want to get a value, there's a function called get. And you're going to have to tell me where is the location of the value that you're trying to get. And again, you can actually find out the size of that array. Let's go ahead and give this a try. So what I'm going to do, I'm going to add 3 elements. I'm going to come here and say al.add. I'll just go ahead and type al.add bb. Of course, it's supposed to be string. And then al.add cc. Okay, so I got those 2 elements. Now, if I want to add another element, .add, and let's say I want to add an element at location 1, and there's going to be a dd. This basically means this dd, let's put it as lowercase dd's, is going to come in this area between A and B, and is going to take the B place, and all the elements are going to be shifted there. So let's go ahead and create a for loop. Integer I equals 0, I is less than al dot size, then I plus plus. And then let's go ahead, system dot out dot print line. Okay, so al dot get and put I here. Let's give this a try and see what are we going to get. Now look at this, A, D, D, B, B, C, just like I thought. Now let me remove in the limit, AL.remove. And I'm going to put 0 here. Now this should remove the first limit, which is AA. Now if I run it again, you'll notice I got DD, BB, and CC. So A is gone. Okay, so this is add, remove, set. Let's try to change values. What I'm going to do here, I'm going to say AL.set. And let's say here, I want to change the value of CC. So I know that I got BB, CC, and DD. So BB is going to be the first, CC is going to be the second. So I'm going to put 2, and I'm going to put CE. And then you'll notice that CC is not going to be CC anymore. It's going to be EE. These are my examples. Okay, so this is the array list, and this is the implementation for the arrays now. The last part is basically what we call the enum data type or enumerated data types. Now, this enum thing is mentioned in a class of arrays, but you should know it has nothing to do with arrays. The only thing that it has to do with arrays is it looks like an array, but it's not. So what is this enum thing? Well, it's a way to declare objects. So since I'm going to declare objects, it's more like a class. Okay, so what does it do? Well, enum basically could help us making your program easier to read. You don't have to do documentation that much, and it makes a lot more sense. Here I got a list of the advantage of using it. It's allow values to be assigned. Only allows values to be assigned. Okay, using enums makes the values type safe. Provides from self-documentation. You can also add methods, which is basically it's out of the scope of this class. So let's go ahead and I'm going to show you just an example of the enum, and then I'm going to try to implement those methods. Let's imagine, and let me just go here and put a new divider. Imagine you want to create a program, and that program basically will be processing the days of the week or the months of the year. So number one, when you declare an enum, it has to be out of the main function, still inside the class, but not as a part of the main function. So we go here, enum, and I'm going to call it days. And I'm going to open a curly brace, and I'm going to call this curly brace. And in this area, I'm going to say Monday, Tuesday. I think it's, yeah, Tuesday. And then Wednesday. And then Thursday. And then Monday, Tuesday, Wednesday, Thursday, Friday. I lost sense of days and time and everything. And then Friday, Saturday, and Sunday. So here we go. I don't know if we need a semicolon at the end or not. Let me just make sure. Do we know? Yep, I kind of guessed it. We need a semicolon here. Okay, here we go. So this is my enum. This is my data type. Now, let me go down, all the way down. Remember, this is the enum that I declared here. What I'm going to do, I'm just going to copy it, and I'm going to put it as a comment here so I can have a look at it instead of scrolling all the way up. Now, let's go do simple operations. The system. I'm killing myself here. Out.print line. Okay, so let's go ahead. Look what I'm going to do. I'm going to type days dot MON. Well. Let's see what we're going to get when you run this. And here you got Monday. That's how simple it is. What if I typed Tuesday? I'm going to get Tuesday. And here it is. Okay, what if I have 2? And here we go. That's what I was expecting. There is no such a TOT. Okay, so that's one of the basics. Now let's talk about functions. Now, we always refer to months with numbers and refer to days with numbers as well. So sometimes people like to think about Monday, the first day of the week. So we'll go, for example, the value 1, even though that's not the case here, but we'll just think about it that way. So what if I want to use in my function days.Monday, MON, but instead of, this is what I'm going to type, but I want to use the number that represents what is Monday for the days of the week. Well, this is what we do. We do have a function here that can help us doing this, which is basically, let's see here, ordinal. Yeah, that's basically what it is. So that's the function here. I cannot copy it, of course. ORDAINL. So I'm going to come here and type. I'll just put this between parentheses. Dot. And here we go. When we run it, and we'll see what does that day is. Basically 0. Yeah, that's how I thought. I was going to start counting from 0. So let me just put, for example, Sunday here. And run it. And you can see I got 6, even though I know it's a 7th element, but again, we start counting from 0. So if I want to just process it as we'll just add 1 to it. So this is the enum. And as you can see here, this is how it works. Again, this is not a variable. This is basically an object. And since it's an object, so it comes with a lot of methods. And I have a long list of the methods here. First of all, I can convert it to a string. Remember, when I just typed, let's just go back here, whatever's going to be printed is not actually a string. It's the object, but this object sum here is not a string. So if I want to convert this to a string, I just have to come here and type to string. And now I'm going to get the exact same results, but now I know this is a string. So if I want to have access to a character, I can come here and type character at, let's say, 0. And you will notice that it will tell me it's S. Now let me take this away just to approve. Immediately you get an error because this is not a string. Okay. String, this will give you the value, equals if you want to compare between two of them, if they're the same or not, and this is going to compare between them based on the values that I talked about, the 1 all the way to 6, and basically you can get a positive, negative, or 0 depending on which element of this enum would compare with which element. Now, of course, we do have another set of methods. This basically methods are associated with the object itself. And what does that mean? Those are methods, non-static methods. So what I do here, basically, I type days.sun or days.anything of any one of those elements, and then after that, I follow it with the function. Now, we do have what we call static methods. Static methods, they don't belong to an object, and all we have to do here is type the name of the enum and then the function, and then after that it will get the job done. Now we do have 2 of them here, value of, and then we have values. The value of basically will accept a string. You type a string here, and it's going to tell you what is the value. So let me just show you how it works. That makes it a lot easier. System.out.println. So I'm going to start by typing days, uppercase, dot, let's see if it's uppercase or not lowercase, value of, and here in this area you tell me, for example, Saturday. Now he doesn't like the value. Let's see, what did I do wrong here? Value, yep. Why are you complaining? Oh, it's lowercase, value of. Okay, so look at here, value of Saturday. Let's run it. He's going to give the Saturday. Now, this Saturday here is not a string. It's basically this Saturday that we have here. Now, the last function, which is the most important one, you can convert this enum to an array of those strings. So how do we do that again? We do have a function called values. And again, this will turn an array of the enum constants. So let's just go ahead and give this a try and see how is that going to work. I need to have an array. But what type of array? It doesn't say here. And contains enum constant. Returns an array with 12 values because the months here is arrays that contain the enum constants. The last function we're going to talk about is the values here. And the idea here is it's really not that big of a deal. So look what I'm going to do. I'm going to come here and create days. Same data type or same name. It's an array. I will call it day. And that basically equal days dot values. And this is basically me converting this enum into an array of a type of days. So let's go ahead and create a for loop. Integer I equals 0, I is less than 7, and then I plus plus. Then in this area, I can come here and create system dot out dot print line, and I'll just go here and type d of I, semicolon. Let me just fix this. Let me run this so you'll see, well, what am I going to get as a result? And as you can see here, I got all the days printed of that array. Of that array, yes. This will end this unit, and if you guys have any questions, remember to send them to me, and I'll be more than happy to answer them. Enjoy the rest of your day. Bye.